I'd like to introduce you to the data model for Corpus Christi. It's quite extensive compared to maybe some other school projects that you've worked on. And I'm going to take each of the sections of the data model in turn and introduce them to you in some detail. One of the key things about this piece of software is it's intentionally internationalized, and there's a couple of terms that you should be aware of there. One of them is internationalization, which is sort of a longish word. It's often abbreviated I-18N, which is an I, 18 other characters, and an N that make up internationalization. The idea of internationalization is that you've created code that can be easily or conveniently translated into other human languages. So we want to have our software here initially work in Spanish and English. We've already got a Chinese translation actually as well. But building the software in the style that allows us to do internationalization is at the heart of all of the design of this piece of software. So internationalization is about the coding and making it possible for the software to be translated into multiple human languages. The other part of this is called localization, which is often abbreviated L10N because it's an L and 10 letters and an N. And localization is sort of the flip side of internationalization, whereas internationalization is providing a piece of software that can be translated. The process of doing that translation is referred to as localization. So we've built the software in such a way that you can map a new language onto it, and the process of doing that is called localization. Now, all of that is done in the database. So the information that's stored about a particular language that you can use the software in is driven from the database. And this first portion of the data model here, you can see I10N, is the rather small number of tables that accomplish this. So there's two key things going on here. One of them is this table called the I18N key, and then there's another one called the I18N locale, and then the I18N value. So the idea here is that in the software, part of the localization process is going to be to assign new translations to particular identifiers that are used in the code. And those identifiers we refer to as an I18N key. And those things are strings written in English because that's kind of the language of the implementation. And they're things like person.firstname or address.city or okbutton.label or things like that. They're references that have some meaning in the context of the software, and those keys are then used to map that identifier to the appropriate translation in the human language that we're interested in. So throughout the software, we'll see all sorts of examples of those I18N keys, like person.firstname. Let's just stay with that one. And what we want to do is provide a mapping from that key to a particular localized version of that word in the localized language. So the other side of this relationship here is the I18N locale. And what a locale is you've seen them in different contexts, I'm sure. They're things like EN-U-S would be English for the United States. There's also EN-U-K, which is UK English. In this application, we're also, of course, interested in localization into Spanish. So one of the locales, that was one of the original two locales that we used in addition to English, was Spanish for Ecuador. So the abbreviation for that is ES for Espanol -E for Ecuador. Now, so we've got these two values, one that's the key that we're going to use in our software, and the other that's going to be an indication of the particular locale into which we want to translate. And those two things need to be brought together in such a way that we can connect a specific translation to the key for a certain locale. And that's the job of this I18N value table. This guy is an associative table. You can see that it's connecting together as if with a foreign key, the I18N key and the I18N locale. So it's establishing a many-to-many relationship between the key and a particular locale, which is exactly what we want to be able to provide localization information. We want to have, for each possible pairing of a key and a locale, we want to have a value that specifies the translation of that particular key into the localization language. So the associative table carries some additional columns here that represent that information. There's a gloss, which is kind of the linguistics term for the rendering of a particular linguistic idea in a certain human language. And then also a flag here that says verified. And you can see that that's a Boolean. The idea here is that when we're building these new translations, what we typically have found is that the developers are going to go in and they're going to go someplace like Google Translate, and they're going to get an initial translation for some phrase, the OK button or the log out or the login or whatever it is. And they're going to put that into the data for that new language that we're localizing into. What we want to allow for is the possibility that they might have gotten that wrong, or that Google Translate might have done things a little bit goofy. And we want to have an opportunity for a native language speaker to go in and verify that the particular gloss we've got in there is correct. And that's what this verified field is. So initially that's going to be set to false. And then when the native language speaker goes through and verifies the particular translations that we've got, they can use an interface that will allow them to check that off as verified correct. The final thing here in the I18N section of the database is a table called language. And this is a way for us to be able to just kind of represent for a particular value or a particular localization, we have a certain set of languages into which we've localized. And that can be used, for example, for putting a menu on the screen that allows the user to select a particular language. You notice that there's a foreign key here to the I18N key table. That's because we want to not only be able to represent different languages, but we want to represent different languages and use the names of those languages in whatever languages we've got available in the software. So in English, the name for English is English, but in Spanish, the name for English is Inglés. So we want to be able to keep track of that information so that we can present the right information for the particular user of the software. Let's turn our attention to the people part of the data model. This obviously represents the people in the congregation or the leadership and so forth. So we have kind of at the center of this is a table called person, and it stores information like first names and last names and those sorts of things, as well as a username, which is a unique identifier for an individual to log into the system, and then a hashed password. We don't store plain text passwords, we store them as hashes. I've kind of used a little bit of an extended syntax here for these diagrams. You can see down here that I've got an address ID, and that points to this weird looking dotted box called address. And that's actually intended to be kind of a connector here on the diagram that refers over to an address table in the places portion of the data model, which we'll talk about later. But rather than have all of these lines all over the place in this diagram and just messing it up, I'm just using this as a kind of an abbreviated way to make that connection. You can see I'm doing the same thing with the internationalization keys up here. And back over here, as you might have noticed when we were talking about the internationalization, there's a connector there that ties into the I18N key. So I've labeled these things with the table that they refer to or with the connection on the other end. So this address is just referring to a separate address in another portion of the database. We have various ways of keeping track of attributes about people. This is quite a general purpose mechanism. So, for example, if we wanted to keep track of somebody who was a Sunday school teacher or a member of the pastoral staff or something like that, we wanted to have sort of a general purpose attribute mechanism that we could use to identify characteristics of people in the database. We can associate that person with multiple attributes, so one-to-many relationship here. Now, the person record captures a fair number of pieces of information that we're pretty much going to want to keep track of for every person in the database. But there's other information that we really can't predict ahead of time that we'd also potentially like to be able to keep track of. So, for example, is this person a part of the men's group or the women's group or the children's ministry, or are they a musician or whatever? So we'd like to have a kind of a general purpose mechanism to store attributes about people. And that's the point of the attribute table here. So it has a particular key, and I guess I should point out here that in the majority of the tables in this data model, we use the identifier ID to represent the primary key for the table. Then, secondly, we have a field here that refers again to an I18N key, and that's the name of the attribute. So it might be worship leader, for example. we don't want to hard code worship leader in English into the database, right? Because we want to be able to internationalize it into other languages. So we don't put the value directly in here. We actually have a reference to an internationalization key that allows us to translate that particular string into different languages by doing the localization that I described in the I-18N discussion. We've also got a type field here, and this is basically going to tell us, do we want to have a string value or an enumerated value, something that we can just type in sort of free form, or is it going to be one of several things? So if we create an attribute like class member, we might want to be able to say, well, this person is a student, this person is a teacher, this person is a discussion leader, this person is the social host or whatever. We'd like to be able to specify different values that are available for that particular person rather than having a free-form text field, which is hard to search on and report on and that kind of stuff. So if the attribute has a particular enumeration, a sequence of values that it can take on, we'll have entries in the enumerated value table here. On the other hand, if the attribute is just an ordinary string, we can just type that in. It's actually going to show up here in the string value of the person attribute table. Now, as you can tell, this person attribute table is an associative entity, right? It ties together an attribute, which is independent of any specific person, to the value of that attribute for a particular person. So the values here in the person attribute table are going to connect the person to their particular value for the attribute. And that could be one of two things. It can either just be a string value, if that's the type of attribute that we're putting in here, or if it happens to be an enumerated attribute that has different values from which the user can select, we're going to store a reference to the enumerated value table from the person attribute. So this thing it actually looks like a ternary relationship because it ties together person and enumerated value and attribute, and technically it is, but semantically it's only going to do one of those two things. It's either going to connect a person to an attribute or a person to an enumerated value, depending on the type of the attribute. And again, the type here is also an internationalized thing, right? Because we're going to have somewhere on the user interface a drop-down that says, okay, you're creating a new attribute. Do you want that to be an arbitrary string, or do you want it to be an enumeration of other specific values? And we don't want to say that in English. We want to be able to internationalize it. So we have a key here that points to the internationalization table that allows us to translate that. The other thing that we can that we can associate with a person is a role. So this has more to do kind of with what the user has permission to do within Corpus Christi. And that'll be more evident in the code. But the idea here is that we could have roles like a super user or a system administrator or an ordinary public user. There's different roles that can be used by the system to determine what's available in the user interface and what's going to be possible in the back end. So we put in a list of roles that are available, and again, those have to be internationalized, so we see that we're referring to an internationalization key. And then we want to be able to connect a person to roles. And it makes sense to keep this flexible, that we might want to have a person that has multiple roles, and of course a given role is going to have multiple people in it, so we want to have a many-to-many relationship, and in this case it's mediated by this associative table, person role, that's just a simple associative entity that refers to the person and to the role by foreign keys. So to make a person part of a role, we add a row in this table that has that person's ID and that role's ID. Next, let's take a look at the places portion of the data model. I should point out here that the abbreviations here, the places and people in I-18N, those identifiers are used kind of throughout the code base and actually in the naming of the tables, which you'll see as you dive into the code a little bit more. So they're not just convenient labels here in the data model, they're actually used in the code. So the kind of the heart of a place is the address of that place. So we've got what you might expect, kind of name, address, city. We don't have kind of the conventional things that you might expect to have if you were just modeling a location in the United States. So a city and a state and a zip code. We've got a little bit more flexible model going on here. So we've got the address, and we're just assuming that that's going to be the entire address. So it's not like address line 1, address line 2. It's just the address, the city that is located in, and then an area ID is really kind of a generic way to refer to kind of a geographic designation that's larger than a city but smaller than a country. So in the U.S., that would be a state, but in other countries, it might be a district or other geographical groupings that are kind of that intermediate layer. So whatever that is, we can store that information here in the area ID. And in order to make that robust, we're going to have that actually be a foreign key that refers to this area table. So we have some ID and then the name of the area. So in the United States, we would have 50 of these area tables, or 50 of these area rows corresponding to each of the 50 states. And then there'd be a foreign key that would refer to the country that would have the United States. In Ecuador, it's going to be something different. In different countries, there'll be other kinds of areas. We also have a country code reference, so that goes to this country table as well. And then to kind of give us as much specificity as we might need, regardless of the particular location in the world, we're storing latitude and longitude information. Now, that might seem a little bit weird, but it turns out that there's a lot of places on the planet that don't really have addresses. And if we want to be able to convey to somebody, where is an activity going to take place, or where is a small group going to be gathering, or something like that, we can't really do anything better than just have the latitude and the longitude. So if there is an address, great, we can use that. If there isn't an address for that location, then we can fall back on latitude and longitude and kind of use a geographic information system approach. Already talked about the country, and then, of course, the country itself is going to have an internationalization key. Notice that I don't have an I-18N relationship here for the name of the area. The reason being that I don't feel like, and this is something that happens multiple times in the data model, there's some things that we definitely need to be able to translate from one language to another, but there's other things that it doesn't really make any sense to do that. The name of the district in which a particular city is located in a given country is that name, and it's not going to be something that's going to be called something different in a different part of the world. People might mispronounce it or something like that, but the fundamental name of that thing is not going to change from one language to another. So if somebody in Germany is talking about the state of Indiana, they're going to say Indiana, not some other thing that is Indiana in German. So this is not translated into a particular localized value, but the country, of course, there's different names for different countries, right? In Ecuador, the United States is called Los Estados Unidos. So we want to be able to provide that information with a translation. The other thing, and here's that address reference here that we saw over in the person area to allow us to give an address to a particular person. And we elected to go this route so that we could have multiple people in the database that all had the same address. So multiple members of a family or family group that live at the same location, we can just have that address in the system one time. Then we also have this idea of a location. So an address is a particular kind of geographical spot on a map. A location is intended to be sort of a subset of that. So if we're talking about the location of a church, well, within the church, there's going to be the worship center, there's going to be the fellowship hall, there's going to be Sunday school classes, there's going to be the offices. And if we wanted to be able to locate things, for example, in the event planning module, we have the ability for you to put in assets like where's the public address system, or where's the microphone, or where's so-and-so's guitar, where is that usually stored if we want to use it for an event. We would like to be able to have a little finer granularity for location within an address, and that's the point of this location table. The groups portion of the data model actually was one of the principal reasons that we got involved in this process in the first place. Our partner in Ecuador was principally driven by small groups. In fact, the church there doesn't really think of the church as something that you're a member of. You're a member of a small group, and the collection of small groups taken together really is the members of the church. So your kind of membership is at a much finer level of granularity, and the church wanted to be able to keep track of how those groups were working, who was in what group, how groups were forming and growing and shrinking and splitting and those sorts of things. So there was quite a lot of attention paid to this portion of the system. And one of the things that became clear after some initial attempts in an early version of the software was that the representation of groups needed to have a little bit more flexibility than we had initially imagined. We thought initially that having a group leader and a group member was going to be sufficient. But then we discovered that there were members of the pastoral staff who were responsible for multiple groups, and essentially they're in charge of the leaders of those groups, and then the group leaders that's in charge of the members of the group. And so as soon as we saw that there was kind of another level of abstraction going on there, we decided we needed to have something a little bit more flexible than just assuming that there was going to be a leader and a member. And this data model reflects that. So first of all, we have here at the that's not really evident here from the diagram, but the person is really the central thing in a group, right? A group is composed of people. So this is a reference back up to the person model. And you can see here that persons can be connected to groups. So here's a group. It's got a name. It's got a description, a flag that says whether or not it's active. Let me take a second here to say that the data model is designed such that we essentially never delete anything. However, if a group no longer is functioning, or it's been, say, a group grows too large and it's split into two other groups, and the initial group itself sort of goes away, we don't want to lose the fact that we had that group at some point. So we don't want to just go ahead and delete this record. We want to inactivate it or deactivate it, and that's what the active flag is here. So if the active flag, whenever you see it in the data model, is false, it's as if that particular instance of the entity doesn't exist. But we want to talk about kind of the relationship between people and groups. So let's just assume that this is, for example, a home group, which is kind of the main focus of the original requirements for the software. We've got, again, a name and a description, and then a type ID. This is, again, a way for us to kind of capture specific types of groups. So this might be a Sunday school group or a home church or a musical group or something like that. We can kind of collect together the types into specific categories so that we can do a little bit more flexible job of doing queries and reporting and that kind of stuff. But the principal thing here is the group itself. And you can see that there's two ways of connecting people to groups. And both of these are associative tables, right? You can see that they've both got two foreign keys that connect a person to a group. And the other one also connects a person to a group. Well, why do we have both? Well, it turns out that as we've thought through how this data model should work, that there's kind of two ways that a person can be connected to a group. The person might just be an ordinary member of a group. So for a home church, for example, that home church is going to have members. So we might make an association between a particular person and that particular home group with an entry in the member table. On the other hand, the person who is the leader or the leaders of that home group, not only are they members, but they also have a little bit more responsibility. So we have a second associative entity called manager that allows us to give sort of additional permission or additional regard to a person as it relates to their membership in a group. And as we have with group type, we've got a manager type here. So this manager type might be, for example, pastoral staff member or group leader or social coordinator, whatever it happens to be for that particular group. So a person can be associated to a group either as a member or as a manager. And we're not really that happy with this notion of manager, because this isn't really a management application, but it's essentially just means somebody who has sort of elevated permission with respect to that group. So for example, one of the things that a group leader is going to want to be able to do is send a message to the members of his or her group. So the functionality in the system that allows a user to send a message to a group is restricted to those persons who are managers of that group. So this is just a way for us to capture that kind of an idea. On the other hand, if a person is only a member of that group, then they don't have the ability to log into the system and send a message to everybody. Furthermore, we wanted to be able to capture this notion of multiple levels of hierarchy. So this manager relationship ties a person to a group. Well, if we have, for example, a pastoral staff member who's responsible for multiple home groups, each of which has a leader with multiple members, what we can do is we can establish a group of the pastoral staff and say, okay, this person is a member of that pastoral staff group, and that group has oversight on on the home church group, right? So we've got this ability to have a fairly general purpose hierarchical relationship built into the system that's really flexible. So in the similar way that the kind of attributes on persons can grow and change depending on the particular application we're putting it to, the intention here with groups, particular home groups, which is where we started, have that same capability as well. The other aspect of groups that we want to be able to focus on is the ability for a group to have a meeting, right? So you're going to have a home group meeting, you're going to have a staff meeting, you're going to have a choral practice or something like that. So we want to be able to keep track of who's attending what meeting. This is a really important metric that our partners in Ecuador want to have because, again, they're driven primarily by the building and increasing in size the home groups that make up the overall church. So they want to know which groups are meeting, when are they meeting, how many people are showing up, who's coming, who's not coming, and they want to be able to use that kind of information to drive the ministry. So if somebody has been attending a home group for 6 months every week and suddenly they disappear for a few weeks, they probably want to follow up with that person. So they want to have information about attendance. So the meeting itself has some characteristics associated with it. When does it start? When is it over? What kind of meeting is it? Is it just our regular weekly meeting? Is it our Sunday picnic or whatever? And there's a location for that meeting, so we refer to an address in the places portion of the database. And then we want to be able to keep track of attendance. So attendance is just a simple associative connection, again, a many-to-many relationship between a particular meeting and a particular person who attended. And we also need to be able to know, well, which group are we talking about? Meeting. So this foreign key refers back down here to the group. So meeting is itself something of an associative table here that connects where something's happening to what group is meeting there, and then we can keep track of who was in attendance. Rounding this out, then we have a relationship here to image. This junction is a little goofy looking here, but image is connected to a group. That allows us to have photographs of the group stored on the system. And then we also have a history table here that allows us to keep track of when people joined or left the group. So we've got a connection to a person, and then the group relationship here to that particular group, and then information about a timestamp, and then whether or not it was somebody that joined the group or left the group. Next up is the courses portion of the data model. Our church partner does very extensive training within their congregation, everything from New Christian 101 to more thorough kind of Bible study sorts of certificates and diplomas that they offer. So if you take a certain number of courses, you're going to actually be awarded a diploma, and we want to be able to keep track of that information. So the first thing to talk about here, I guess, is the course. So this is a particular course that you can take as a part of the church. It's got a name and a description, and again, an active flag that says whether or not it's currently being offered. Courses can have prerequisites. So in order to take Christianity 102, you got to take Christianity 101. Or maybe you've got to take an intro to the New Testament course before you take the Pauline epistles. So the prerequisite table captures those relationships. And this is a little bit odd looking in the sense that it's actually an associative table that refers to the course along both of its foreign keys. So what we're basically saying is we've got some course, that's one of these things, and in order to take that course, you're supposed to take a prerequisite course. So that's this, which is also one of these things. So it's not as weird as it looks. It's just a way to sort of establish a sequencing of the courses that are supposed to be taken. We've got here at the other side, so courses are taken by students. So student is somebody who is enrolled in a course. And you can see here that they're, of course, connected to the person record, which is the same one that we've been talking about throughout. And this basically just says that that particular person is taking a certain course as it's offered. Well, which course? Well, it's going to be a course that's being offered at a particular time. So we might offer the Christianity 101 course at the beginning of every quarter or something like that. So we've got the single course that is going to be persistent, but it's going to be offered multiple times. So we've got a foreign key to the course to indicate that which course is being offered, a little bit more description. Maybe this course is the Christianity 101 course, but it's actually being offered in the classroom in the new wing or something like that. the number of people that can sign up for it, and again, whether this course offering is currently active. So a student is going to enroll in an offering of a course. And then when the student completes the course, if they do, we're going to add another piece of information to this course completion table, which is, again, a simple associative table that connects a course to a student that says this student finished this course. Notice that we're not saying this student finished this course offering, because the course is going to be offered multiple times. We don't really care when the student took it, although we do know that because we've got a connection to the offering. But we want to know whether or not they finished the course itself in terms of making progress toward a certificate or a diploma. We also have that information here, the idea of a diploma. So the church has a system where if you finish, 4 courses, you receive a certificate or a diploma. I don't know what they call it exactly. So you might take, 4 courses in New Testament and get a certificate or a diploma in New Testament studies. So the diploma has to connect to a particular number of courses or specific courses that you have to take in order to be able to be awarded that diploma. So diploma course establishes a many-to-many relationship between diplomas and courses. And finally, when the student is awarded the diploma, we want to keep track of that as well. So here's another associative table that says this diploma was awarded to this student, and we also want to keep track of when that took place. In addition to the particulars of the course and the diplomas and so forth, we want to be able to do some of the business of just offering the course. So one of the things that we want to be able to do is keep attendance. So we've got another attendance record that's quite similar to the attendance record for groups. So a particular offering of a course is going to have multiple meetings. So a course has many offerings, and offering has many meetings. So these would be the specific times at which that course offering met, the next 4 Saturday evenings or something like that. We'd put those course meetings in here, and then when the course meeting took place, the teacher or the teacher's assistant could keep track of who actually showed up at the meeting to know whether or not that person is making progress in the course. The class meeting has a relationship to the location. Again, this is the location within an address. So, it's classroom 12B at the main church location. And it's also got a reference to the person who's teaching the course. So the teacher ID connects to the person who's in charge of that course. The events portion of the data model is intended to capture events at the church. So this might be something as typical as a Sunday service. It might be a special event, a special concert, a retreat, other types of things that go on. Basically things that are going to show up on the church's calendar and that we need to have some planning to go into to be able to make sure that we have the space and the time and the people and the equipment that are going to be necessary to hold that event. So the event has the description and title as you'd expect, the start and end time of the event, and location where it's going to take place, and so forth. Over here on the right side of event, we've got some details of the needs that event is going to have. So for example, maybe there's a team associated with that event. That might be, say, a worship team that's going to show up for worship time at a retreat. So here's an associative table that connects events to teams. So this would be, a team might be a particular worship band, and then that particular team is going to have members. And so we've got another association here that connects people to the team, and whether or not they're currently active in that team, and then also whether or not the team is active. So this description would be, Dave's worship group or something like that. And then here, these are the members of Dave's worship group. And if that worship group is assigned to work this event, there's going to be an event team association that's put together. We also have an event person entry. You can think of these as teams of one, I guess. But this is going to probably be something like the main speaker at the event, the worship leader at the event, the guest speaker that's coming for a retreat, that sort of thing. So it's individuals that we need to keep track of that are associated with this event so we can give them information about scheduling and updates and that sort of stuff. And this ties the event to a particular person and adds an additional element here of the description to say this is the worship leader or something like that. We also, for an event, want to be able to have assets available. So this might be something like the public address system that we need to bring to the off-site venue so that people can hear us. So that asset here is is kind of the central idea here that says, here's a thing, and we want to know where that's located, right? Well, it's the sound system that's stored down in the southwest corner of the basement. That's what the location would be. And then that asset might be part of a collection. So we might have, say, 10 microphones or 2 different drum sets or something like that. So we can have a collection of those things and then associate the particular asset with that collection. And then when an asset is associated with an event, right, we want to use the older drum set for this particular youth retreat. We're going to create an event asset row that connects that particular asset to this particular event. So all these things here on the right-hand side of the event have to do with kind of the logistics of hosting this particular event. On the left-hand side, we have information about the participants in the event, by and large. So, for example, we want to be able to allow people to sign up to attend the event, right? We're having a youth retreat. We want to allow the young people in the church to be able to sign up for that. So the user interface would need to provide some information about an upcoming event and allow a user to log in and say, I want to go to that event, which would create an event participant entry in this table that would connect that particular person to this particular event. We've also have the potential for groups that would want to attend an event. So, our home group is going to go to the weekend retreat, next Thursday or something like that. So we can also connect an event to a group, and the associated table here is going to go to the group table instead of the person table. We also have in mind being able to keep track of different sorts of attributes for events in the same way that we have attributes for people. But as you can see here from the little sticky note in the ERD, this isn't totally fleshed out yet. We'd like to be able to keep track of images that can be used on the website and used for promotions and to just kind of keep track of events. And so there's an images portion of the data model. Here at the center of this is the image table itself. It's got a unique ID, a description, and then the path here is actually going to be a path to the location where this image is stored on disk. Just to kind of keep things flexible, we're not assuming that the image itself is going to get stored in the database, although it could be. It's more common to have it stored externally in the file system someplace. The rest of these tables, as you can see, are all just associative tables that connect that particular image to a group or a course or a person or an event. So, and these are, of course, associative tables that establish a many-to-many relationship between the image and the group or the course or the person or the event. And the idea here being that we can have multiple images that are stored and associate them with different other portions of the data model. Now, the decision here to create separate associative tables to connect images to very specific portions of the rest of the data model is one of 2 possibilities, right? This is a little bit more verbose, but it provides us some additional referential integrity. I can't, for example, store an image for a course in the group table because it just doesn't connect to that in any way. This could get a little bit out of hand as we added more things for which we wanted to keep track of images, and it would be also plausible for us to relax the referential integrity in the data model and have just an association between an image and something else in the database, and the something else information would be carried as an additional attribute on an associative table. But as for right now, we've got this approach. We could change that in the future if we wish. We also, the final table here in the image is connecting the image to a location. So if we want to keep track of where we were when we took this picture, we can not only associate the image with its group, course, person, or event, but also with the location where that was being held. One final table in the data model right now is called error report, which you can kind of guess what it's for. The idea here is that when something goes haywire on the server or is detected from the client and reports to the server or whatever, and we want to keep track of something that's of interest to the developers or the system administrators, we want a place to put that information. So this error report is just the description, the time that it took place, and then the endpoint is the URL, basically, where that error occurred. So we can kind of keep track of some information that can be used to try to debug the system in the case of failure.